Welcome friends. Formation of PDE by eliminating arbitrary functions. In the previous two videos we have discussed formation of PDE by eliminating arbitrary function. Single function was there, but here two functions are there, f and g. Therefore the PDE will be of the second order we are going to get. Okay, that's why what we'll do, differentiating this given different equation by partially with respect to x, all the first 5 partial derivatives we will find out. First two first order dou z by dou x and dou z by dou y, like that dou square z by dou x square, dou square z by dou x dou y, dou square z by dou y square will find out first. Then we will try to eliminate the function f as well as g and its derivatives will eliminate. Okay, let me find dou z by dou x partial derivative with respect to x. Let me call it as b. If you are differentiating partial with respect to x, it will become f dash of x plus ay into x plus ay differentiation is 1 plus g will become g dash of x minus ay into partial difference of x is again 1 and ay is 0. And next, differentiating with respect to y, dou z by dou y equal to q equal to, while differentiating partial with respect to y, again it will become f dash of x plus ay into differentiation of x is 0, a plus a into y is become a plus g dash of x minus ay into minus a. From these two equations only, it is not possible to eliminate f dash g dash. That's why we're going for the second order. Differentiating 2, again partially with respect to x, I am going to get it as dou square z by dou x square, or that is nothing but dou by dou x of dou z by dou x. Meaning is dou z by dou x I am differentiating again partially with respect to x. Let me call it as r. While differentiating again partially with respect to x, f dash will become f double dash of x plus ay into differentiation of x plus ay with respect to x will become 1 plus g dash differentiation will become g double dash of x minus ay into differentiation of x minus ay with respect to x again will become x. Let me call it as okay. Next, again I have to differentiate 2 partially with respect to y now, that is dou by dou y of dou z by dou x. Dou z by dou x I have differentiating partially with respect to y, or I can write it as dou square z by dou y dou x, which is equal to, short notation is yes. Therefore this one I have to differentiate partially with respect to y, that is f dash will become f double dash of x plus ay. This one I am differentiating with respect to y, therefore x is 0, a will come here, a into y differentiation is a. Like that, g double dash of x minus ay into x minus ay partial differential with respect to y will become minus a. Like that, one more partial derivative can exist here. This one I can differentiate partially with respect to y, that is dou y of dou z by dou y, that is nothing but dou square z by dou y square. I will denote it by t. And while differentiating this one partially with respect to a, already a is there, you can take a common, or as it is you can differentiate. Let me differentiate. F dash will become f double dash of x plus ay into, already a is there, into differentiation of x plus ay with respect to y, 0, a into y is a, again a square it will become, plus g double dash into x minus ay, already minus a is there, partial differential of x minus ay is again minus a, therefore it is minus a square. For our convenience, let me take a square common from here, a square, that will become f double dash of x plus ay plus g double dash of x minus ay. From all these equations P, Q, R, S, T, I have to eliminate F dash, G dash as well as F double dash, G double dash, or I can substitute for Z. You have to think any operation you can do. Okay, then very simplest one is in this particular example T is equal to A square into F double dash of this. Therefore R equal to F double dash of this is there. I will substitute this R equal to here. Then we will get the required equation. Therefore T is equal to A square into R, where R and T are the R is dou square z by dou x square, T is dou square z by dou y square. Therefore this is my required partial differential equation, which is of second order. As we mentioned, if the two functions are there, it is equal to two number independent variables. Therefore we are going to get the second order PDE. Okay friends, continuation with this, I would like to solve another example which is containing two functions again, f and g. Again, whenever two functions we are going to get, let us differentiate them partially with respect to x and y twice. Means all the first five partial derivatives let me find. Call this as equation number 1. Therefore dou z by dou x equal to p equal to, with respect to x I am differentiating, and y into f of x is there. This is a function of x and it is y. No need to apply the product rule as it is. I will write it as y into f dash of x plus x into g of y is there. G of y is constant, partial differential of x is 1. Therefore g of y, let me call it as equation number 2. Like that, dou z by dou y is equal to q, partial differential with respect to y now. Again f of x is constant, partial differential of y is 1. Therefore f of x plus here partial difference with respect to y. Therefore x is constant, g dash of y. From these two equations only, it is not possible to eliminate f dash and g dash as well as f of x and g of x. Therefore again differentiating this one partial with respect to x, dou by dou x of dou z by dou x, I will call it as dou square z by dou x square, which is equal to r. Now differentiating this one partially with respect to x, y is constant, partial differential of f dash of x will become f double dash of x plus g of y, I have to differentiate with respect to x, therefore it will become 0. No function of x is there, 0. Call it as equation number 4. Similarly, dou by dou y of dou z by dou x, differentiating dou z by dou x partially with respect to y, what I am going to get is dou square z by dou y dou x equal to, I will call it as s, short notation, differentiating with respect to y this one. Therefore f dash of x is constant, partial differential of y is 1. Therefore I will write it as f dash of x plus, and partial differential of g of y with respect to y will become g dash of y. Let me call it as equation number 5. Like that, I can differentiate dou by dou y of dou z by dou y, which is equal to dou square z by dou y square. It is a t. Differentiating q partially with respect to y now again. Therefore f of x is constant, that is 0, plus x into x is constant, g double dash of y. Let me call it equation number 6. From all these 6 equations, I have to eliminate two functions and as well as their partial derivatives. Then how can I eliminate? Any substitution is required? No. Okay. F dash of x plus g dash of x is here. But here f dash of x, g dash of x is there. G dash of y is there. but the coefficient is x is multiplied, y is multiplied. If both are same, then I could have added, then d dash I can substituted. For this one I could have substituted for this. That's why what I will do, equation 2 I will multiply by x, equation 3 I will multiply by y and add them. Then I can substitute for this f dash of x and g dash of x. Okay, equation 2 into x plus equation 3 into y I will do. Okay, what is equation number 2 into x now? Left hand side, xp equal to xy into f dash of x, okay, plus x into g of y, plus for equation 3 I will to multiply by y, that is, and I have to add them. Okay, that is equation y into q equal to, here I have to multiply by y, xy into g dash of y plus y into f of x. I have to add these two equations. Then what I'm going to get, xp plus yq is equal to this xy I will take common adding them, and this I can write as f dash of x plus g dash of y plus this is x g of y plus y into f of x. Therefore xp plus yq is equal to xy into f dash of x plus g dash of y is nothing but our equation number 5. I can replace it by yes, plus x g of y plus y f of x is nothing but our equation number 1, given x into g of y plus f of x is nothing but z. Therefore I can write it as xy plus z. Here we have eliminated all the partial derivatives. This is my required PDE, and here p, q, s is there. S is nothing but dou square z by dou y dou x. It is the second order partial differentiation. Therefore this is the second order PDE. Thank you friends.